Welcome back to this class. This class is about the problems in Nmr spectroscopy. Last class we have seen some important points from the Nmr spectroscopy. Now I'll see some important questions from the Nmr spectroscopy which have been asked in the previous examinations. Now I'll see some questions. The first question is, in the H1 Nmr spectrum of dilute solution of mixture of acetone and dichloromethane in CdCl3 solutions. CdCl3 is the solvent which is not generally used in the Nmr spectroscopy. Exhibit two singlets, both of them are singlets in 1:1 intensity ratio. The molar ratio of acetone and dichloromethane in the solutions. They have asked about the molar ratio of acetone and dichloromethane in the solutions, but the intensity of that exhibit in the Nmr spectrum is 1:1. But when you consider this acetone and dichloromethane, the number of hydrogens in acetone is 6, but here the number of hydrogens in dichloromethane is 2. Their intensity ratio is 1:1, but the hydrogen ratio is 6:2. When you rearrange this, their molar ratio is, when you rearrange this, 1:3. That means their molar ratio should be 1:3. Then only you will get, when you multiply this, 6:6. When you multiply this, 6 1 is 6, 2 3s are 6. So they are become 6:6 only when you do this rearrangement. So their molar ratio will be, this acetone should be 1 and the dichloromethane should be 3. So then only you will get 6:6 ratio. It will be like 1:1. So this is like a simple one. We can expect this kind of questions for the examination also. Now we'll go to the next question. This is one interesting question. The structure of the compound which displays the following spectral data in IR spectrum. The IR spectrum is given, both the IR and NMR spectrum, and 13C carbon 13 spectrum is also given here. The IR spectrum values are 1690 and 1100 centimeter values are given here, and the NMR spectrum values are, this shows the IR spectrum value at 1690. This we can find out, come to the conclusion that it should be like a CO groups. Since its value is slightly lower, it should be for a ketone. And 1100 values for the, also for a CO groups, separate CO linkage, like a CH3 CO linkage for centimeter. And delta values have been given here, 2.8 singlet for 3 hydrogen, 3.8 singlet for 3 hydrogens. Both of them are singlets, they are separated distantly. And 6.9 double H, J value is 8 Hertz for 2 hydrogens, like that. 7.8 double H, J value is equal to 8 Hertz for 2 hydrogens. From these, J value is 8 Hertz. Both of them have the same J value. That means these two hydrogens are coupled, and they are giving the, both of them are giving the doublets. This 7.8 and 6.9, we can come to the conclusion these are for the aromatic hydrogens, because aromatic hydrogens will give value from 6 to 8, up to 8 they will give. So these are, and at the same time 8 Hertz means they are coupled cis. So it clearly shows that they are the aromatic hydrogens. So on the value at 13C NMR spectrum, from the 13C NMR spectrum, the values are given here, 197, 165 and 130, 127 and 114. These 4 values shows that these are for the aromatic carbons. These are for the aromatic carbons. We can expect from 110 to 160 we can expect. So these 4 values for the aromatic carbons, and 56 and 26 are here, and the value, one value at 197 for the carbonyl ketone groups, carbonyl groups. Here I have given you some standards for a carbonyls. If it is a ketone, for a 13C NMR we can get value from 205 to 220 for a carbonyl ketone. If it is for an aldehydes, its value will become 190 to 200. If it is for a carbonyl, like an ester groups or an acid group, if it is ester or acids, will get around, it should be the lowest one, 170 to 185. But here we will get the value for 197. So this is from the options and also from the standard values. You can conclude that this 197 will be the value for your keto groups. Here the keto groups 105 to 220, but even because it is aromatic keto groups, its value is slightly lower than this. So it will value 197 will be for the ketone groups, and also from the value IR value 1690 and 1100 value shows that these are for the aromatic ketone, and CH3CO group is there. So from these options, these are the 4 options. Since I have told already there are 4, it is giving 4 aromatic hydrogens. These 2 are same. From aromatic hydrogen stage it's giving only 2, like 6.9 and 7.8. That means only 2 hydrogens are there in the same environment. Only 2 types of hydrogens are there. From these, here these 4 hydrogens, 1 2 3 4, these 4 hydrogens are different environments, so we can expect 4 hydrogen from the aromatic stretching, but from the given data value we are getting only 2 values, so this is not the option. These 3 options are for the aromatic hydrogens possible. All these 3 are possible, but from the CO stretching and from the 13C NMR spectrum we can come to the conclusion that this third option, because CH3O will give the value around 100 centimeter, and this value will give 1690 per centimeter, and these 3 methyl groups will give a singlets. So but here this is an ester groups, but if it is an ester groups, the carbonyl stretching, carbonyl 13C NMR value will become 170. It should be very lower, but here it is not the case, so it is not the ester groups. So we can come to the conclusions. Third is the right option for this questions, because ester groups, if it is an ester groups, we would have get the value at less than 185, like that we'll get, but here value is slightly bigger. So this is not the ester groups, it is a keto groups. Now I'll go to the last one. The compound that exhibits the following spectral data values. Here we have given only the NMR spectral values. NMR spectral data is given here. The NMR spectrum delta value is 8.0 double H. J value is 12.3 Hertz for single hydrogen. Here this J value 12.3 clearly shows that it may be in a trans coupling with the other hydrogen. 7.7 double H, J value is 8.0 Hertz. That means it is coupled in a cis manner for 2 hydrogens. And 6.8, it's a doublet, J value is equal to 8.0 Hertz for 2 hydrogens. So these 2 hydrogens 7.7 and 6.8 are coupled in a cis manner. And 5.8 doublet, J values 12.3 Hertz. This value, this 12.3 and this 12.3, these 2 hydrogens are coupled in a trans. Since it is coupled trans, we can come to the conclusion it is not from the aromatic hydrogen, because in aromatic all the hydrogens are cis manner, but aromatic hydrogens we have get only 6.8 and 7.7, only 2 for the aromatic, and these 2 are the different environment. They are out of the aromatic group because they are coupled in a trans way, but in aromatic ring all the hydrogens are coupled in a cis manner, so these are not in the aromatic hydrogens. And 3.8 singlet for 3 hydrogen and 3.0 singlet for 6 hydrogens. This 3.0 singlet for 6 hydrogen, that means like a propyl groups, isopropyl groups, they are connected, and 3 hydrogen for a singlet. This is also separated methyl groups. So we can get all this informations and fix this in the from the options. Now these are the options here. From the data we have seen, there are only 2 magnetically equivalent hydrogens are there in the aromatic ring. Here in the first ring, 1 2 3 4, all the 4 hydrogens are in a different environment. They are magnetically not equivalent. All the 4 different 4 data values we should have got, but From the data we can come to the conclusion this is not the option. Here also this 1 2 3 4, these two are same, these two are not the same. 1 2 3 4 hydrogens we should have got different values, but this is also, these two are not the options. But when you come to these options, here these two are magnetically same equivalent, these two are magnetically equivalent, but here one keto group is here, this hydrogen, here one hydrogen is there, here one hydrogen is there, they are coupled trans. From the data we can come to this. But here this is the right option. These two hydrogens are magnetically equivalent, giving value at 6.8 hertz, 6.8 delta value, and 7.7. These two are magnetically equivalent. This is the CH3O groups. This will give you a singlet, and these CH3 groups and CH3 groups are magnetically equivalent at 3.0, and they give the value for 6 hydrogens, and these are the hydrogens giving 8.0 or coupled trans. So these are the things we have seen today. I hope these informations are much more useful to you. We can expect questions based on these concepts. Thank you so much for watching this session. Thank you.